991% of the speed of light. You can never do anything as fast as the speed of light, except light, so the particles will just go closer and closer. But the more important is how much energy is in each of the particles. Just move a little bit further here. Okay? Can you hear me well at the moment? I will put this later, but here it should be still fine. This is a map of the CERN accelerator complex. Before we arrive at the LHC, particles went through a number of accelerators, because you cannot just start from particle from zero in the LHC to its maximum speed. So depending what particles we have, it takes a different path. Today, as you know, you can later go to all sides, not just point 2. You go to the shuttle to the main side or to Pavassan. It will be difficult to see another underground because the queues are long, but there are many things to see where the queues are short, and you can learn more about the other accelerators as well. So particles go through a number of accelerators. As I said, among those it goes through the booster, through the PS, then to the SPS, which is the other large one, and then the LHC, which is here. The LHC collides particles in different spots. This is one of them. We call it point 2 or ALICE. Then there's CMS, Atlas, and LHCb. So we can collide at 8 points. We at the moment collide at 4 different points. And at these points we build so-called detectors. So it's nice if you have a particle collision. However, that doesn't tell you anything if you cannot measure what comes out of the collision. For that we build so-called detectors, which are the big devices which we will see. And they are built with different scientific aims. That's why they are different. They have different size, different weight, but more important is the technology used. The experiment we are going to visit, the ALICE experiment, is optimized to analyze collisions in which we produce many particles and to find out the particle type of each of these particles. So we use for that lead ions. While, for example, Atlas CMS, they use collisions of protons. They are optimized for as many as possible proton collisions in a time to look for very rare things, like the Higgs boson, which you certainly have heard of when it was announced, its discovery in 2012. So, in a sense, the physics idea comes first, then people see how could one construct a detector, what's the technology we could develop, and these are very long processes. So, the first time people thought about the LHC was when the previous accelerator in the tunnel, LED, was already running. So, around 85, people started thinking, and things became from ideas became documents of hundreds of pages, research had been done, and so on and so on. So it's a very long process. At the moment we started the process for a larger accelerator, which is called, at the moment, FCC, the Future Circular Collider. Maybe it will change its name. But the concept is that it's a 100-kilometer ring, which goes around the Salève, below the lake, and back to here. So that's just the concept for now. People have found out how much it would cost, the technology you have to develop, and how long it would take. So if that would be built, we talk about collisions in 2040 or 2050 up to 2070. So people have, you see, people in this very expensive project also have to think very far ahead. And maybe even if I don't look that old, I will already be close to retire when it starts. So this is a bit strange if you would start working on a project where you can actually never see it finished. So one has to then find the joy in the smaller elements, in the research for something, and one develops components and so on.
Are you specialized into something, sorry?
So I'm a physicist myself, so I do data analysis for the ALICE experiment, but I also do detector construction, where at the moment, when we see later the detector, we will see part of the outside of the detector, and the inner part will be empty because we just have taken everything out to replace it by a better one. We were running now since 2009 for 10 years, and we replaced this now in this year and next year. That's why you cannot all go down, because we have stopped everything for 2 years, and we replace these detectors, and I work also on one of them, which is the one closest to the beam type. It's a pixel detector. You can imagine it like you take many camera chips, so what does pictures in your camera, you put them in a cylinder and many layers, and then when a particle goes through, it will leave traces in each of the layers. You can draw a line and you know that a particle was there. Okay, I think it's